Welcome to everybody. Today's session is for even more pointers. And also we're going to look at recursions. So how to write recursive functions, and we'll see how these things works. So let's start with the first one, the more pointers. For the more pointers, we're going to try to loop over multi-dimensional arrays and understand how those things work, pointers on pointers. I think we'll have a grab on that very quickly. So for now, we are in the Visual Studio Code. This is where we're going to write code for the purpose of this session. But anyway, for any other projects on the LX, we should, of course, use the VI or Emacs for as editors, code text editors. But for now, we are using VS Code so that it's much easier for everybody to see and understand the file structures and those kind of things. I'm going to change the theme color, make it much more visible. And we're going to open a file, a new folder. Going to call it right. So here, I hope that you guys can see the screen.
You can see the screen.
Great. So here we are in the main .c file where we're going to write things about pointers. So for the first exercise, we'll try to look at how to loop over multi-dimensional arrays. What are multi-dimensional arrays? And understand that multi-dimensional arrays are just things, understand how to use things like pointers and pointers, the concept behind it. Great. So here, let's start by creating a function. The main function, we'll call it int main void. Then we'll return 0. Then let's include other header files, the stdio library. Great. And let's declare a variable called matrix, and it will have something like 3 lines with 5 columns. And let's declare another variable called num of line will be free, and we'll call it num of column. This will be 5. Then we're going to declare another variables. For the lines, we're going to call it line 0, and we're going to call the other variables columns 0. So here we are looping, we're going to start looping over the matrix and initiate each fields inside of it. Great. Let's add a command here. Initiate the matrix. So we start a first loop. The first loop will be for line is equal to 0, line lesser than num of lines. Changing the name of the variable, yes, num of lines. And we say line plus plus. Then after that, we can say for on each line, we are going to display the columns. Great. So we're going to say for columns is equal to 0, columns lesser than num of columns, next. Then we say matrix. We specify the index of the line, then the index of the column. Then after that, we initiate the line columns by this value, line times columns. So what we're having here, let's open an Excel style sheet. We'll see what is happening. And then after, we're going to display the content of this matrix-like structure. Now here is a blank worksheet. So in our matrix, we have columns and lines, and we have 3 lines, and we have also how many columns? We have 5 columns. So in the style sheet, I'm going to highlight 3 lines, 1, 2, 3. Then columns 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Great. So now I'm going to add a color on those lines. It will be green, yellow color, and that's it. So for the first cell in this representation of the matrix, we'll have column 0 times line 0. We'll have 0 here, 0 here, 0, 0, and 0. And here we'll have column 0 times line 1. So we'll have 0 here too. 1 times 1, 1. So here 2 times 1, we'll have 2, 3, and 4. And here we'll have 1 times 2, 2 times 2. So we have here the column 2 and the line 2. here we have column 3, and line 2, it will be 6. And here we have column 5 with index 5 and line with index 2. So here would have 10. Great. So this is basically what the matrix should show. And the next loop we're going to write in our code will display the content of the matrix, and we should have something like that. Let's go back in the code. So here we're going to type in the code to display the matrix. The matrix. The same thing, we loop over the lines. So for line is equal to 0, line lesser than num of line, then line plus plus. Next, we loop over the columns. So on each line, we're going to loop on the columns. So for columns is equal to 0, columns lesser than num of columns, column plus plus. Then we use the printf function to print the cell in the matrix. So each cell is located at a specific line in a specific column. We're going to use the printf function. We add in a space, then matrix, the line index, then the column index. Then when we display the columns on a line, we're going to move on to the next line. So we are going to specify a line break so that when we display a line, we want to go to the next line and display another line. So let's open the terminal. So now we're going to type the command gcc, then the input file, then the output file name. There is an error in the name of the file. I'm going to clear the screen. gcc main.c, the name of the output file, then run the command. Great. Let's execute and see what happened. Oh. So main, I'm going to change I'm going to change the terminal to git bash. Okay, now that's good. So let's execute the code. We see that we have been able to display the matrix. So this is the first line, the second line, and the third line. So what we should understand is that things like that, these things, what we're using here is pointers on pointer. So the matrix variables is a pointer to on another pointer. Let me explain what's happening here. So when you type in matrix, something like that, you will have an array of 3 elements. But then when you type in 5 like that, you will have an array of 3 pointers that point to 3 arrays, that point to other array, to five 3 arrays, that 3 pointers that point to um, uh, 3 memory locations that contain um, five elements. So we having here 3 arrays which contains 5 elements. So basically, we can loop over the same matrix in another way by using pointers, so we can understand what's happening. I'm going to delete the code and rewrite it again. So let us declare a pointer is called array. Okay, so this is a pointer. I'm going to set it to null, the default value. It's always good practice to set pointers to null when you initiate them. So next, we're going to loop over the matrix, but this time we're going to use our array pointer. So for line is equal to 0, line lesser than num of lines, then line plus plus. So what you have to understand here is that each line is an array. So what we can see is that we can do something like array is equal to matrix, then the line. Then after that, we can say, okay, so for column is equal to 0, column lesser than num of column, then column plus plus. So we have an array on each line. So now we are trying to display the content of that line represented by an array. So we're going to say array column. We can even rename the array variables, but what we have to understand is that the matrix is actually a list of 3 arrays that have 5 elements in them. So that's why when you type in something int array, an array pointer, so you can say matrix, then the line index. This also is a pointer. You assign this pointer to the array pointer. And since it's an array, you can still loop over the array and display what you want. We're going to add a line break. Great. So let's compile this code and see what happens if we're going to see the same display. So here, there is a bit of problem. So we specified the line number, the line, then the column, num of columns, then column plus plus, then columns. The display is not what we expected. This is because we did not initialize the matrix before displaying it with this loop. So what I'm just going to do will be to copy the same loop and initiate the matrix. So here we can just type in something like array, then column. Then we set it to line time column. Great. Now let's execute again. So we have the same display. We had a matrix which has an array of three arrays in it. So 3 pointers to arrays that contain 5 elements. Then because of that, we can declare a pointers array. So a pointer to an integer value. Then we can do an assignment like that. We can take each line of the matrix which is pointing to an array, then assign it to the array variables. Then we loop over that array to display the content or to set the values. So the matrix basically is a pointer to another pointer. Let's delete all that and see what is a pointer to a pointer. If you have, let's say, a pointer A, we have a value A, for example, like that. Then we have a pointer to an integer that contain the address of the value A. Then we have another pointer to a pointer which contain the address of the variable P. So what we have to understand is that each of these variables are just variables. They contain values, and the values type, the values they can contain may change because of the type, but basically they're all variables that store values. So this is a pointer, and this is another pointer. So a pointer to a pointer, we can do as many pointer to pointers. For example, something like that. Oh, sorry, I forgot to add PP. We can add a pointer to another pointer. And next, we can also add a pointer to a pointer to a pointer. And let's add one more line, a pointer to a pointer to a pointer to a pointer to a pointer. Great. Now let's try to display the values. Let's say A is equal to 10. Let's try to display the values by using dereferencing. So I can say something like printf, I want to display the value or all these pointers are pointing to. So for the first pointers, this is a pointer to an integer. So we use the dereferencing operator, then the name of the pointer. So we do dereferencing once here. Then next, let's try to display the value of A using the second pointer, the pointer to a pointer that point to a value. You can still do that. So we have to use dereferencing twice. We have to tell the compiler, hey, we want to dereference first. Then second, that will be the value of A. So we dereference first time, then we dereference second time. We had to add the parentheses. Oh, the variable name, I forgot. Okay, so this will, the first start means we dereference for once. So then we get the address, the value that is contained in the pointer, which is an address of another pointer. Then we use the dereferencing operator to get the value of the address to which this other pointer is pointing to. The same things for all the others. So we can have a pointer to pointer to pointer to pointer to pointer to a value. Let's add other things. It's kind of funny. So all these will display the value of A. So I'm going to type in something like that, A. So this is A. Oh, I forgot to add the parentheses. Great. So we're going to say this is A. And now P is pointing to A, then A value. Then next, we have PP, the variable P is pointing to the variable P, which is pointing to variable A, which is pointing to the value. And next we have PPP, the variable PPP, pointing to the variable PP, which is also pointing to the variable P, which is also pointing to the variable A, which also point to the value. And the third one, we have P, pointing to the variable PP like that. And which also point to this one and point to that, which also point to A, which also point to the value. So we can continue like that on and on and on. So like that. So basically, as long you know how much how much deep is the referencing, so you knows which how many dereferencing you should use or you want to use to get access to the value you're looking for. So let's run this code. We'll have gcc, then main.c, the name of the output file. Okay. Let's execute. And here you can see that what happens here, you see that the values displayed here, they are all 10, 10, 10, 10, 10, because we use the right number of dereferencing. So in here, we have the first line here, we have the value. Then next, we have a pointer to that value. Then next, we have a pointer that points to the pointer that point to that value, and so on. So as long these are variables, you can still create pointers. You can still create other variables that store their address. So the number of starts depends on the type of the previous variables. So for the first one, this is our first, we're pointing to an integer address. And the second, we're pointing to a, a variable that is a pointer that point to an integer address, and so on. Now let's go back to our matrix. For example, now before we go back to the matrix, I want to show one last thing. Let's say we want to change the value inside A because we know the address. We're going to change it from this pointer. You can say we want to change the value to 12.